Perfect, thank you. Oh, good, this works. You don't have to shout to the back of the room. Well, first of all, I want to say thank you for making it to the final session. I expected a lot less, so I'm very pleased to see somebody show out for it. And I'll make it worth your while, I promise. Or at least I hope so. You'll be the judge of that. So let's get straight into it. Got quite a few things to cover. Automation and cybersecurity. I mean, this isn't a term that's new to us, right? It's buzzword. I mean, RSA, I think this year, automation is one of those top 5 buzzwords in the kind of reviews of what people are talking about. It's been around for quite some time. What I really want to focus on today is how automation is going to help us achieve better risk outcomes from a cybersecurity perspective. And I'm going to kind of move into a couple of gray areas around data analytics and using automation to help kind of solve other risk problems, not just in security. Because times have changed, right? And we've become much more capable as a technology, as an industry, around automation. Machine learning is driving that. Some other functions are driving that. So let's talk about what that can do for us as well in a GRC and security perspective. So, yes, I've been around the industry for quite a bit. I'm not going to harp on about what I've done, but I've kind of seen quite a few things. I've spent a lot of my career in the startup industry, so working for kind of vendors, taking new technologies to market. After getting out of uni, studying psychology, so what an interesting career progression it's been to go into security, but probably one of the most useful educational backgrounds I could possibly wanted in this kind of game. So I'm going to bring a lot of this experience and hands-on experience into the presentation, I hope, and we will try to get some Q&A in at the very end, so you can kind of throw some questions at me. So before we jump into it, I mean, what's interesting is stats and figures, can always be tweaked to fit any kind of presentation scenario, but I've been looking at a couple over the past sort of few weeks, looking at some of the latest things, kind of try to find what citations are referencing others, and I've kind of come down to this latest sort of soundbite, right? So the average enterprise, and these are kind of organizations with about, several thousand users plus, are seeing about 120,000 alerts across all of their systems, right? We're not just talking security, per week. Now, if we take that 120,000, how many do we think are malware related or security related? Well, a report by the Ponemon Institute reckons that 17,000 a week of that 120,000 are malware, right? Security alerts. So I thought, well, let's go further, right? Of those security alerts, and having spent a lot of time in the Sauk myself, how many are actually actionable? How many can we do something with on average? There's a lot of studies that support this. You can go and check up the data behind what I'm saying. Well, actually, it's a lot less than 17,000. It's about 20% of that overall figure is deemed to be actionable by analysts in a lot of different surveys. That's kind of the average. Some as low as 15, some around 18, but 20 kinds to be the number you hear. So of those 20% of alerts that are actionable, how many can you actually respond to as an average organization or enterprise, right? Because we don't have limitless time. And it's a lot less than 17%. It's 4% of those actual alerts that do get responded to. And I'm going to come back to some of these stats later on because they're really important in why automation has to be adopted in the most, effectively, but really quite seriously expedited in organizations to help us really battle the cybersecurity problems we're facing today. So the story kind of starts with machine learning, right? Should we trust the machines? Can we trust the machines? And it's always an interesting question because when we talk about automation and cybersecurity, automation can be seen as a risky thing to do. It can be seen to be very high false positives, depending on where you're applying it, what we're talking about. And we do see a lot of industries averse to kind of automating, unless it's kind of production manufacturing where it makes a lot of sense. But in security, we like to control the eggs in the basket. We like to control the pieces of the jigsaw puzzle. We like to be able to know what we're doing because we feel that the people know best. And that's true to a certain extent. But automation has been around longer than we think. And it all goes back to a revolution in the phone industry when the iPhone was being released back in 2007. I know quite a while ago before that handset was pushed out. So Apple were at a position in the market, right? The iPod was doing phenomenally well, and they needed to kind of innovate, do something different. So the iPhone was being worked on for a number of years, and we're getting to June 2007, and around Q1 of that year, there was a huge challenge. They had spent a great deal of time at Apple developing phenomenal applications, a great user interface. It was all very innovative, and it kind of spoke to the Steve Jobs kind of way and thinking of managing the company and bringing new ideas to market. But the challenge was they couldn't get the keyboard to work. So, you try to write and by the way, I think we'll probably agree that I still don't know if the keyboard works as well as it should do today, but that was the big issue. They weren't able to make it a usable function of the phone. So they actually stopped all production on the apps and user interface. And they got all of the developers together, all the chief developers in the room, and they said, we need to fix this problem or else we cannot launch the iPhone. So there's a YouTube video here I reference in the decks, which is something you'll be able to get a copy of through online sources. And it's a really good 4-minute video on this whole story. But the summary of the story of automation in Apple is this. The developers all came with weird and wacky ideas about how to make the keyboard work. And one engineer stood up, and we don't know his name. For some reason, he's just called the keyboard engineer. But I'm sure he'll come out of the woodwork at some point and explain who they are. And they presented a keyboard that worked. You could actually type in the word "the" and it would work. You could type in the word "and" it would work, or more complex letters, and it would work. No longer was this fat fingering thing happening that had been occurring all the time in the previous iterations of the product. So they asked, how did you make it work, right? And you guessed it. He said, I've used machine learning. I used predictive input analysis machine learning to figure out what we think the probability is of the next letter being in the sequence. And, well, what does that mean functionally for the keyboard? How does machine learning work? Well, when you type or touch a letter on your phone, there's a hit area over the key that expects you to hit that letter. So with Apple and all phones now, when you type the next letter, machine learning predicts what it should be based upon the user input and the language settings, and it increases the hit rate. So rather than just a square around the letter or a circle, depending on how your keyboard's laid out, the hit rates area, or the surface area for the expected hit rate, becomes much larger. So I'm typing in the word "the," for instance, or "to." I type in T first. The phone will try to predict what my next letter is going to be based upon my behavior, based upon dictionaries and so on and so forth. And it will make O in the word "to" the bigger hit rate. So even if you touch I or P, or maybe the top of K or L, it'll still give you the O, which is why sometimes it can be infuriating. You're trying to type a word that isn't quite common, and you're getting another letter close to a letter you've pressed. It's because the machine learning is trying to predict what you're going to do, so you can start to speed type and use it much more effectively. So what's interesting is automation has been in our lives a lot longer, and we kind of use it every day. So I'm not saying this is the way that we've solved cybersecurity principles, but it's just to show you that machine learning as a function is something that really has been driving a lot of the core things that we take for granted in all of our technology lives. So we'll come back to that story later on in the presentation. Let's kind of talk about the challenges we have from a security operations perspective. Well, if I was to sum it up, the biggest problem that all security teams, audit teams, risk teams face, it's kind of this picture. It's a big pile of log data at the end of the day. It doesn't matter what you're doing, what applications or services or systems you're running, they generate data. And that data comes in the form of logs and all packets or flows, depending on how far down the OSI stack you want to go. And we have to deal with that. We have to take this big pile of data, which is growing at an exponential rate, every day, every minute, every second, every nanosecond, and make a decision about what's going on. And in theory, this is what it looks like, right? That stash of log data on the left, whatever it is that you're doing, right? I'm not just talking about security. It can be any data input whatsoever. If you're an airline, it can be how your planes are flying. If you're a car manufacturer, it could be the manufacturing line data. If you're a physical security company, who's badging in and out, who's doing what? That all generates log data. And then you have to ask questions of it, or your analyst team do, to make sense that's relevant to the business, right? There isn't silver bullet questions or answers to security. You've got to find out what questions mean most to your company, to your business. What's going to affect your brand? What are your user and data assets? What are the things you need to find to protect your information and your data? And in most cases, that leads us to this kind of chasm of having to build stories, having to piece together lots of pieces of the jigsaw puzzle and come up with our different versions of what this log data is trying to tell us, to try to get to a point where we can do something about it. And doing something about it all depends on what we're trying to achieve. It isn't just security outcomes. And that's problematic, and here's why. If we think about, and let's go back to security now, SOC workflows in practice are notoriously difficult. I've worked in SOCs, I've been a part of Tier 1, Tier 2, Tier 3 analyst teams. I've seen this pain, I've lived this pain, I still live it with customers today. When you get the dreaded alert, there are lots more questions that come off the back of that single alert. First thing I want to figure out, is this an alert that I care about, right? We go back to that stat I told you before, right? Only 4% get responded to from that initial 17,000 that are noteworthy, right? And only 20% of those 17,000 are deemed to be noteworthy. I've got to figure out which of those I actually want to go and investigate. And there's more questions besides. And this workflow doesn't just start at the alerts. What if it's a user-based alert? What do I care about when I see something happen on the user side, when they authenticate to something? I want to know who they are, where do they come from? Are they accessing something they normally access? Is this a legitimate credential? And we could go off into zero trust here if we really wanted to and talk about how that's kind of helping. I don't know that it is necessarily, but that's another talk track for the day. But these are some of the questions you'll have to see your analyst team ask to get some sense out of a user-based alert. Forget about users, talk about connections in and out of your environment and your network. Well, where are they connecting from? Have I seen this connection before? What's going on? It's very, very hard to get context out of just these alerts in isolation. And even if you take these alerts and you try to do some level of correlation to try to add up the pieces to come up with a number that tells you that maybe there's an issue, you still really haven't got to the end of the challenge. You still really haven't got context as to what's going on. And the purposes of this illustration is to explain, if you don't understand the investigation mindset that goes on in your business, and maybe you don't work in a Sauk or maybe you interact with them depending on what's going on, when you try to get a picture of what goes on in that security operations team's sort of daily lives, you kind of get an idea of how difficult it really is to make sense of what I should do or if I should do anything at all about each of these alerts that are firing. And I'm going to sort of wrap this up into more of a kind of succinct story in a moment. And actually, where analysts spend most of their time is in the raw data. They're going across a plethora of tool sets from multiple vendors across multiple systems. If we talk about kind of SCADA networks, there's a lot of air-gapped environments, a lot of third-party legacy systems that can't be fed into a correlation database like, that gives you SIM, correlation rule outputs, et cetera, et cetera. So no matter what kind of business you are, it's very difficult to truly centralize and converge all of the data to try to get a one sort of picture of what to do and what to do next and how to do it. So, you're spending hours and hours of time here, and the interesting thing is if you ask two analysts the same question, in my experience, I've rarely ever got the same answer. You'll always get a different answer because it's all about the human factors and performance and the mindsets that you apply. I'll look at problems in a very different way to another analyst because of my experiences and what I deem to be important to me in the business. Same for analyst B. So this is the challenge. We're still kind of working on legacy tool sets and processes to try to solve modern day problems, and that's broken. So then we kind of move into, let's talk about the Sauk maturity model. So, Gartner, Forrester, they're all talking about new ways to become a mature Sauk operation or to mature your GRC and kind of risk analysis profile. Well, I mean, this is revived. It's been around for some time, the Sauk nuclear triad. I think this was first cited back in 2006 when I did some research on it. And it's not often I disagree with Gartner, but I do think they've got it wrong here. And I say that, with confidence of 20 years of doing this kind of role. Visibility is something we know we need, and the industry is certainly not arguing with the fact that we need more data and more visibility. But that's not the challenge today. Right? We've got more data today about everything that's going on than we've ever had in the history of humankind, in the history of technology. So the visibility challenge isn't the problem we face. It's what to do with that data. We don't need more noise. We need more sense of what we're seeing. And then you look at this triad, and we talk about a lot of organizations focusing on network detection and response technologies and looking at the packet flows. Go, the bad stuff is going to be in the data flows. Yeah, you can detect stuff in data flows, but you can't detect everything because not everything is malicious, right? A lot of the major breaches we're seeing over the past several months and years are using legitimate credentials to do legitimate things, but in an illegitimate fashion. You're not going to detect those functions by just using network traffic analysis alone. I go into organizations that just care about network detection and response, and they're forgetting about the importance of looking at what's happening on the endpoint, and they're forgetting about the importance of correlating that data and making sense of it. So this Sauk triad is kind of a misleading concept, and it's something that I'm about to kind of lift the lid off in a moment when we talk about how automation is kind of delivering a new framework, a new best practices approach to solving not just the visibility issue, but the risk outcomes problem, and that's what it's all about. And I was listening to a podcast the other day, at one of the Spotify podcasts on security, and one of the CISOs, I think it was of Levi Strauss in the US, headquartered out of San Francisco, said that security doesn't drive the business drives security. And that's an interesting way to look at it. We often sometimes see security as kind of the flagpole, the flagship of any organization. And yes, if an organization gets breached, then the security team get blamed, and it's kind of seen as where we should be focusing most effort. But without the business, we don't have a security team. If we're not selling product, if we're not out there and we're not sort of providing a service, we don't have a security function. So from our perspective, what we want to do is not have security be something that slows down the rate of business operates. It's actually something that should enable it, and we should be looking at the business first, with security supporting that. And I'll lend some sort of credence to what that means when we talk about how automation helps. And actually, if you talk to the analysts in SOCs, they'll tell you a couple of different things, right? See no evil, hear no evil, speak no evil. The amount of analysts that I've worked with and spoken to that simply just drop incidents off the radar, they just don't have the time, as evidenced by the stats I shared earlier. The signal-to-noise ratio is at an all-time high. We really are at a point where we're just overwhelmed. We cannot deal with all the noise we're hearing. And some of that isn't noise. I mean, I can go back as far as Target to prove that story, right? And we all know about that breach. It was there. It was in the data flows. They could see the breach happening, but it was too much going on at the time to actually take note of it. And the same could be said for some of the most recent breaches that we've also seen too. And then the biggest problem, the existential problem to security analysts and security teams today is this final one. How do you differentiate between normal and abnormal? Yeah, because a lot of the APT groups today are targeting credentials because the credentials are king. And if they can get in and look like one of your organizational users, it's really, really hard. I don't care what level of firewall or endpoint tool you have to detect when a legitimate user is doing what they normally do, but farming data to other points of the location or creating jump hosts to move throughout the network. It's a very difficult thing to track. So what's the perception across the business versus the reality? Well, you go speak to a lot of board members, and they'll think that when you talk about security, this is kind of what's going on here, right? It's just burning cash, and it's a cost center they wish they didn't have to worry about, but it's a necessary evil. And I really haven't seen many boards give me a different view on what the security or the compliance and risk teams are doing for their business today. It is changing, but it's a slow change, in my opinion. Then if you ask the SOC managers what their security teams do, some of them will tell you they're absolute, demigods, and they somehow make magic out of absolutely nothing. Others will probably say, these guys are just a waste of time. All they do is sit there and look at screens all day and do absolutely nothing. But the reality is, a SOC analyst's job, a governance risk compliance team's job is this. And this hasn't changed in the past 20 or so years, right? This is a consistent challenge that we've all been doing, just not in the right or most effective way. We've been taking lots of bits of information from lots of different data sources and trying to build a picture. Because it's only when we understand the picture can we actually understand the in context of the problem. And this is what we need to be able to do to effectively respond to what's going on, to understand where our biggest risks lay and our lowest risks lay. And this is where automation can help. See, I was actually coming in here this morning, the Uber driver was talking about what do I do? I said, I do cybersecurity stuff. Anyway, long conversation. I'll sum it down to the salient point. He kind of said, well, what are we doing about all the future threats? What's happening in the industry as we're moving forwards? And I said, that's a complete misnomer. Why are we concerned about future threats when we haven't even solved how to solve the legacy problems? This is why we're being breached. We're not able to get this sort of complete bucket of data, make some sense of what's going on, to figure out where we should even start our response and mitigation process. We have to solve the legacy problem before we can even start to think about how to solve the future problems. And I really do stand by that. Again, from a SOC analyst perspective, we still aren't getting this right. And this is where automation really does become a game changer. If applied correctly, this is the key thing. So let's have a look at machine learning. Let's talk a little bit now about the automation process. So the connection graph is a piece of machine learning kind of functionality that's been around for some time. This isn't new to the industry. So what a connection graph does is it takes variable inputs and basically creates connections between them. It builds a story, more or less. And it doesn't matter where in the kind of life cycle of a flow of data or access to resources or assets happen. Connection graph decides when something is connected to something else. So I log into a network. The next thing I might do is connect to a device or to a Citrix server or to an application in the cloud. But the original point of entry was authentication to a server somewhere or a VPN login from another country. Then after that, I went to this location. Then after that, I went to this application. And you start to build out this kind of spider's web view of sorts as to what that event history is across all of the user's activity. And once you're able to sort of create this connection graph, you're able to start to apply a level of analytics to it that maybe gives you a much more insightful view as to what's occurring and what's happening. And I'll talk about what I mean through kind of machine learning and statistical analysis modeling in a moment. So connecting the dots is the most important thing when it comes to being able to truly understand what's going on from a risk or a compliance or a security perspective. And this is kind of one of the most core functions of machine learning. I mean, Google, I think, started off with this kind of technology, way back in the day. It's become very popular in endpoint detection tools. I think the vendor Cybereason kind of uses this. They do in-memory connection graph analysis, which is great to see because this is the kind of stuff we need to form a baseline of normal versus abnormal, and then we can start to ask questions of what's going on when we look at this connection graph. And really, once you've got this kind of flow, you can start to then say whether that's a user sort of initiated event or an asset initiated event or whatever it might be, show me what happened from the point of that first file, that first log, that first data flow, right through to the end. Give me a story, a day in the life of this particular user and or asset, and follow it. And when we follow it, we can then start to do more interesting things, as follows. So this is where machine learning kind of kicks in, right? And there's lots of machine learning algorithms out there, oh my goodness, and there's new ones being sort of created all the time. We talk about neural network learning and stuff like this today. The old ones are still working very effectively, right? So, supervised and unsupervised models and so on and so forth. Well, let me talk about unsupervised learning, looking at essentially the differences in rates between certain events. And then you'll start to get the kind of foundation, the analysis for how automation can help remove the need to do all of this manual search and pivot today and all this manual storytelling that you have to do to kind of figure out what's going on. So if you take kind of machine learning algorithms and you apply it to a set of structured or unstructured data, depending on what the source is and the machine learning technique that's being used, let's look at it from this perspective. Let's just say, I don't care what the log source is. I don't care if it's a user VPNing in. I don't care if it's badge access to a building. I don't care if it's a coffee that you take from a coffee machine. It doesn't matter what the data is. I want you to identify three things in that data stream. I want you to identify who or what the data relates to, when that occurs, and what the rate of occurrence is. So if we apply this to a VPN kind of connection model, it'll make a little bit more sense. So if I'm looking at user A and I'm modeling using machine learning all of their VPN activity, what I'm going to look at is how many times have they connected from each country they connect in from. And you kind of get this pattern. User A is connected from VPN over the US, and then they've done it yet tomorrow, and the day after, and the day after. And over a couple of days or weeks, you get hundreds of VPN logs that tell you that the most common source for this VPN is the US. And let's say over 6 months, they jump around and they go to different countries. You kind of start to get these bar charts that show you the different variations. And then with machine learning or statistical sort of modeling, you can say, right, statistically speaking, this is the baseline. We know that these countries are the most common. So what happens if in day 14 or day 54 or day 362, there's a VPN from China? Okay? Well, now what machine learning will tell you is that is way below the baseline. I've never, ever seen this user connect from China before. Now, you didn't have to ask that question. Machine learning told you automatically that that was not a normal piece of activity. Let's go back to the coffee machine analysis. I ordered lattes every day. and then for some reason, 400 days down the line, I order, I don't know, a cup of tea. Well, that's an anomaly. It may not mean there's a problem, but it means something's changed. So what we need to do with machine learning is look for anomalies in isolation and do a little bit more than that, right? Because anomalies by themselves don't paint the full picture. And by the way, it's not always about China, right? It could be from any other country. So what machine learning is there to do is tell you normal from abnormal. And by the way, normal isn't just below the line. If I see a huge spike in activity from Ukraine, or maybe from another country, that's also abnormal because it's a lot more than I would expect to see over that period of time. And that can point to the start of something very serious in your organization, but in isolation, it's not enough. So let's just take that kind of machine learning function and just play with the idea for a moment, and then let's start putting it into practice in terms of how we'd apply it in an organization. So if we go back to kind of the alerts problem that I talked about a little bit earlier, let's kind of take you through a typical story of a traditional kind of malware threat today. So a legitimate user VPNs in out of hours from China. Well, as a security operations team, how would I even know that this is a problem? Unless I'm proactively looking for geotags for China and then getting those alerts, I wouldn't know. And what if it's not China? What if it's a malware threat from a legitimate AWS source that's been compromised in the UK, but it's a particular AWS host or environment that I've never seen before? Again, how would I know that that alert's a problem? I wouldn't, right, in reality. What about malware on the host X, right? Well, how many analysts care about what malware fires? I mean, it all depends on the risk score based upon what the firewall, the malware vendor tells me. But in isolation, it doesn't really mean a great deal. And now this user accesses a database. They query the payroll table. Again, am I even going to care about that in isolation? I'm probably not in all respects. And then there's a data upload to the remote location by that legitimate user of that database table. Well, there's your data breach. And you had 3 key points at which you could have detected that something wasn't right before you got to the point where the horse bolted the stable. So if we apply the machine learning and the automation functions I've just been talking about, here's kind of a different way to look at that data. So let's say it's me, right? I'm the user that's logged in. I log in from VPN over China. But it's an abnormal login, because I don't normally log in from China. I normally come from the UK. So you get an alert, but with a risk score attributed. And I'll show you what this looks like in a minute. Then the next thing you see is, well, I've never accessed the networks I'm accessing before, because machine learning knows what I do. It's creating these connection graphs every day. It knows where I go. And all of a sudden, it sees me access a database. Well, I don't normally access those databases, and I don't normally do it from China. So 1 + 1 is now equals 2 in terms of combined risk score. And we start to bubble up to the kind of the top of the food chain of things that analysts want to care about. But let's play it out. So now the machine learning knows everybody in the environment. They know what Richard does, John does, Peter, whoever the users are. And it can say, well, I've never seen any other user do this before, so I'm going to add some more risk to this activity. Then I jump into the network and maybe I drop some malware from my remote location. Well, that malware is probably going to fire. If it doesn't, okay, that's okay. If my EDR tells me there's new processors showing, that would be abnormal. Oh, this process is fired on this user's machine. It's never done that before. And machine learning tells me it's never seen this across the entire organization. I'm not having to write the rules to do this, right? This is automation at its finest happening in real time. So now I get more risk score. So the analyst sees these 100 alerts, and they get this one bubbling up to the surface going, VPN login from China, access to network resources they've never accessed before, some new type of malware that seems to be firing off new processes. It's only Richard that's doing it. Nobody else is doing it. Accessing this database, it's copying files to these locations. Before you even get to the database access, it's bubbled up to the top. Machine learning has added the risk and a sort of attributed risk score to each of those key areas without anybody having to think about that problem. And that's where we talk about machine learning and automation really helping solve zero-day problems as much as they're helping legacy issues. So it's all about the story. I mean, if you ask any analyst what they care about, it's the intent. I see hundreds of alerts a day, if not thousands, depending on the SOC I'm dealing with. I need to know the intent of the problem before I can understand what's the risk to the business. And it's really hard to attribute business risk to security risk if you don't really know the story that's going on. You know, VPN, that happens all the time. People firing malware, that happens. People getting emails from locations they never get emails from before. It happens all the time. But you show me an alert that says, I'm getting an email from a domain I've never seen before. Nobody else has ever got that email in the company. And that email is trying to connect to a known bad domain. And they're trying to download a file that's been blocked, thankfully, by my firewall. So threat intelligence has worked. But that's important. The context behind that event isn't just phishing email, malware alert. It's the story that's been told that tells me that's probably a targeted campaign against my organization. Now it's time to send out a user education awareness update instantly to get people on the ball about potential phishing or targeted phishing against my organization. That's kind of proactive, predictive security using automation to help you get there. So I've only got a few minutes left, and what I want to do is kind of take you down the path of an APT lens using machine learning functions. Now, one of the things I kind of skimmed over, which I really just want to drive home, is machine learning by itself gives you the anomalies. It tells you what's different, right? We saw that in my kind of bar analysis chart. But you need to understand risk to get that kind of context. And that's where we call on the automation function of what's called statistical anomaly modeling. And what that does is saying, statistically, this is the line. How far above the line do I need to be to increase the risk score? So if I'm 10% above the line, the risk deviation is 10 points. And with these machine learning algorithms, you can tweak that, right? You can decide in your organization what's more risky, what's not. For instance, if you've gone through data classification projects, the most underperformed task and most under-reperformed task in organizations to date, then you might say, well, anything that happens that's abnormal to these assets, I want the risk to be off the charts. I want that to get to the top of the analyst table every day. Or you may not care. You may just want the algorithm to do what it does. But you have to decide, or let the machine learning decide, what those risk deviation scores will be and which ones will bubble to the top quicker. So machine learning finds anomalies. Statistical anomaly modeling tells you what the risk deviation is. And together, you get that story. So keeping all that in mind, let's bring this to a real-world kind of context. Let's talk about threat hunting without having to do too much work off the bat in a more effective way. So I'm going to pick on a well-known Russian APT group, Cozy Bear. And this is essentially the blueprints or the persona of how this APT group operate. And if we think about how they operate, imagine the old way of looking at that data without automation. So this group, and there's two APT groups linked to the same. So there's two bears that are in the Cozy Bear APT group world. They have known, as of this particular analysis, 2016, there was 876 IPs that they were known to come from. Okay, that's probably double by now. But back then, when this analysis was done, this is how it worked. So are you going to fire an alert every time your threat intel shows you an IP address associated with APT28? And if you do, that's 876 potential alerts on a bad day that's added to the additional alerts that your analysts are going to have to deal with. That's not scalable. So let's say you go, right, well, I can't possibly alert just on source IPs because that's just noisy. So let's go to the spear phishing subject tag that the APT group would have used, right? If I see the subject line, I want to alert. That's actually not a bad alert. That will tell you something is potentially being targeted. But we talk about the pyramid of pain for APT groups. All they've got to do is change a couple of characters of the subject header, and your rule that now fires is completely defunct. It doesn't work anymore, all right? But let's move away from that. Let's just talk about the vulnerabilities itself or the particular malware it drops. Again, we can detect on these points, but there's so many variations of this malware now that we couldn't really say that's an effective way to detect this APT group in my organization. And then if we look for the command activity to the known domains they talk to, again, DGA is wreaking havoc around the security industry, and very cleverly created DGA malware is even harder to detect these days, even if we're just looking for where they're communicating to. So that doesn't really scale. So the challenge is, if you're looking at indicators of compromise in isolation and trying to find APT group activity or the next big data breach in your organization, you're going to have a lot of noise to sift through before you potentially find the problem. And it comes back to this again. You look at what these guys are doing. Your analysts are going to be spending days and days and days in here. And I'll give you an interesting sound bite again. So what's the average time to land and expand for APT groups? Okay, and I hopefully get this right, because I always get it wrong by a couple of minutes. But let's talk about Russian APT groups, right? They are the fastest, and this was a Wired report done only in February this year, so it's actually quite recent stats. Russian APT groups will land and expand within 18 minutes and 49 seconds, okay? So once they're in, it takes them less than 20 minutes to move elsewhere. So you think about the age-old security problem. Okay, there's the alerts. Let's go chase those alerts. And you're kind of following the criminal, if you like, down the pathway whilst all the damage is being done ahead of them. So 18 minutes is a very, very quick period of time to be able to land and expand. So then the next group, I believe, is the North Koreans. They'll take about 2 hours, I believe. It was the stats, 2 hours and so many minutes. Then you go to China. I think they're at about 4 hours, and then Iranian groups are the next on the list in the top 4, and they're a little bit over 4 hours, okay? Now, what's the average time to incident triage and investigation and organization? Well, a study done only this year by Security Magazine showed that the average admitted to security incident investigation time was 4 hours. 4 hours, okay? So if you can... If you're taking 4 hours to respond to incidents and these guys are expanding within 18 minutes at their quickest point, you're in a very difficult situation if you're trying to do things the old way. So we are familiar with this story. We use machine learning to look for abnormalities. We risk score the abnormalities using machine learning again and automation, and we get this story of what's going on. So how does this get applied to a real-world APT group? Well, APT3, another interesting APT group, and you can go read up about them. This is actually what they do. This is how, if we do persona modeling of APT3, this is how they get into your environment and how they expand and how they gain a foothold and how they exfiltrate data. So they'll create a scheduled task using legitimate credentials, typically phished, okay? Or they might do some kind of credential stuffing to get in, right? Because everybody doesn't like to choose secure passwords or change them, and it can be easy to get into environments that way. But regardless of how they got in, they create a scheduled task, and here's where they create it. This is their modus operandi. Once they've got that scheduled task run, then they try to set communication on uncommonly used ports. These are the port numbers, apart from 81, but 1913 is uncommon. Then they use PowerShell to download malicious payloads and create reverse shells and things like this on the environment. And then they set up remote desktop protocol for persistent access in and out of the environment across the jump hosts. This is another group that's able to jump in less than a couple of hours around each of the hosts. And then they create accounts for overall persistency that will survive reboots or rebuilds of machines. So if you're talking about applying behavioral analytics, machine learning functionality, you're going to be one step ahead of each of these techniques, regardless of how they change them. It doesn't matter what element they change here. Because you're looking for the baseline anomalies, you're going to catch it. So how about let's stop looking for just scheduled task creation? Why don't we apply, well, let's see when hosts get things stood up for the first time, like first install of a service or creation of a service. Let's look if that service is new for that user and for the organization, for the group, and the time of day it occurred, and all these other things that we can look for. Let's focus now on the uncommonly used port stuff. Well, should we look for whether that's a normal or an abnormal inbound, outbound port that we're seeing, right? Because our business operates the way our business does. If we see ports we've never seen before, then somebody will know if that's legitimate or not. But I don't want to guess what the new ports will be. I want to use automation to tell me when something's changed and then give me the risk differential, the gap analysis of that. And that list goes on and on and on. But this is a very practical way to apply that automation in what's normal and abnormal, and then risk score the abnormalities, bring it all together in a story so that I can actually decide as an analyst in seconds, right, minutes at most, whether I have a problem and I need to escalate or do something, or whether I can move on and close down that ticket as potentially something that's normal activity. So I appreciate this session didn't mean to get as technical as it had done, but I really wanted to delve into the kind of, as much as I could do, into the machine learning functions and the stuff that we can be doing better today to drive much more better incident investigations, to be able to support what the business needs to know. Do I have a risk? And if I do, what was the entire story? Therefore, where do I go and start to mitigate and fix the problems or educate? So that's kind of really going to wrap up the story for today. I hope that you found it interesting, and I hope maybe we've got a minute or so for Q&A. If not, I will absolutely hang around and take any additional questions. But thank you very much indeed for your time.